As AI grows smarter, the risks grow stranger. In this episode, we'll explore frontier challenges, whether it's generative AI hallucination, autonomous agent drift, and systemic fragility. We learn why control problems amplify with capabilities and how governance must evolve to prevent cascading failures across global systems. We'll discover the policies, safety testings, and transparency practices that can protect humanity's future with AI. We have reached a point in human history where intelligence itself has become infrastructure, not just data or code or computation, but thinking systems capable of creating, reasoning, and acting at a scale no single human can match. This is what we now call frontier AI. Models so powerful, so general, and so deeply integrated into everything from finance to defense to healthcare that they don't just serve industries, they shape them. But with capabilities comes complexity, and with complexity comes risk. Frontier AI isn't science fiction, it's the new infrastructure of intelligence. These models don't just process data, they shape decisions, market, and shape trust. They are creative, adaptive, and unpredictable. But when creativity meets liability and autonomy meets opacity, risk stops being technical. It becomes systemic. From trading floor to classrooms, from media to defense, AI is now a participant, not a tool. And governance, that's no longer a checkbox, it's the new compass. Boards, CROs, and leaders must define or redefine controls. Licensing frontier models must define auditing alignment, measuring transparency the way we once measured capital. Because the real question isn't can AI think like us? It's will it act for us? So, what is frontier AI and why does it matter? Well, frontier AI refers to the most advanced class of AI systems. Large, general purpose models like GPT-4, Gemini, Claude, LLM-3, whose capabilities stretch across multiple domains: languages, reasoning, coding, science, and decision making. These models are trained on enormous data sets using trillions of computation. They exhibit emergent behaviors, abilities not explicitly programmed but discovered. Why does this frontier matter? Well, because this is where human oversight begins to blur and machine autonomy begins to scale. It's the point where innovation meets uncertainty, where can we build it becomes should we. Welcome. Welcome to this part 7 of the series on AI risk. This is your host Savit Vittal Salian. We have covered the topics as shown. Now we are entering the frontier of AI risk. The agenda for this video is as shown. So again, welcome back. Let's start the journey. This is your host again, Savit Vittal Salian. Namaskar. What is frontier AI? Frontier AI refers to the most advanced, large scale artificial intelligence models whose capabilities approach or exceeds human level performance across a broad range of cognitive tasks and whose misuse or failure could create systemic, cross sector, or societal level risk. There are four aspects to frontier AI. Scope. These are foundations or general purpose models such as GPT-4 class, Claude, Gemini, LLMS3, or similar that can be adapted for many applications. Could be finance, healthcare, law, defense, etc. So that's the scope of frontier AI. From a scale perspective, these are trained on massive data sets using billions of parameters and high performance compute. They demonstrate emergent behaviors, abilities not directly programmed or predicted. That's from a scale perspective. From a risk perspective, because of their broad reach and autonomy, frontier AI models can carry dual use potentials. They can drive innovation or amplify global risk. Could be misinformation perspective, cyber threat perspective, economic disruption perspective, or bias at a large scale. So that's the risk aspect. From a governance implication perspective, these models now require special oversight, including licensing, transparency, red teaming, compute governance, and post deployment audits under what regulator calls as frontier model governance. So, in summary, frontier AI represents the top end of capabilities and the top tier of risk. Systems powerful enough to transform industries but also to destabilize them if it is misaligned. They require aviation grade governance, licensed, tested, monitored, and continuously aligned with the societal safety. Think of frontier AI like a next generation nuclear fusion. Immense potential for progress, but operating at an energy level that demands collective safety protocols and global stewardship. So, traditional risk governance assumed bounded systems wherein there is data in and there are rules out. Whereas frontier AI demolishes these boundaries. Generative, autonomous, and self improving models are now decision participants, not just tools. These systems learn and compose beyond human curated data sets. These systems interact across open systems through APIs, plugins, agents, and diffuse instantly via open weights or APIs. The risk parameters now stretches from source code to societal cognitions. Now, what do you mean by traditional risk governance assumed bounded systems? We discussed this earlier, but let's try to understand what it means. Traditional risk governance framework, especially in finance, IT, and compliance, were built around close, predictable systems. These systems had defined inputs, explicit rules, and a deterministic output. In short, data went in, rules were applied, and predictable decisions came out. Governance could therefore rely on policies, control checklist, and periodic audits because the system's boundaries were stable and knowable. From a technical perspective, the traditional systems followed rule based logic. Think like core banking systems or an ERP workflow, wherein every input type and business rules were predefined. Changes, if any, required version controls, required approvals, and definitely required testings. The failure modes were finite and traceable. That's the traditional systems. Risk management could thus focus on access control, data validation, change management, and could rely on the transaction logs. Because the logics were transparent, auditor could literally see the rules that produce the decision. By contrast, AI systems are open and adaptive. Input can be unstructured. It could be text, image, behaviors, or any data. Now, logic is statistical and not a rule based. Output would vary probabilistically, not deterministically. So, the old model, data in, rules out, no longer holds. AI systems are non bounded. They learn from changing environments and generate new patterns, meaning the risk parameter shifts constantly. From a management perspective, for governance leaders, this statement means traditional controls assume stability, whereas AI driven systems require dynamic oversight because behaviors evolve post deployment. In traditional IT, you could lock down the risk once and maintain it. In AI governance, you must continuously sense, measure, and adapt risk. Hence, new governance disciplines have emerged, including model monitoring, human in the loop reviews, life cycle risk management instead of static sign offs, and cross functional oversight between data, compliance, and ethics. Example, in traditional system, in an AI loan approval case, the rule is if the credit score is say greater than 700, approve it. Inputs and logics are known, fixed, and are documented. Governance is review the rule table, test for accuracy, and look at the audit logs. That's the traditional way. But in AI driven credit models, the model learns pattern across hundreds of variables. Logic is statistical and dynamic. Decision boundaries changes as new data arrives. Governance must track model drift, bias metrics, and fairness thresholds continuously. So, bounded systems allowed one time control, whereas AI systems demand continuous assurance. Hallucination or misinformation risk. This is a case where probabilistic text generation produces factual inaccuracy at a scale. We have three countermeasures from governance perspective: output verification layer, the RAG or retrieval augmented generation with trusted corpora, and post processing filters. Let's try to understand each of these countermeasures. Output verification layer, the first countermeasure. It means independent logic or tools that check the AI outputs before they are shown to the user. Think of it as a quality gate between the AI and the outside world. Example, fact checking modules that compare the AI answers to the known sources, or logic layers that validate numerical or regulatory claims, or confidence scoring systems that suppresses low certainty outputs. From a governance perspective, it helps create traceability between input, output, and validation. It enables accountability: who verified what and when. It supports assurance reporting. Example, all public output passed through a verification threshold. Analogy, it's like a spell checker for truth. It doesn't change how the AI thinks, but it makes sure what leaves the system is valid. So that's the guardrail, categorized as a output verification layer. The next is retrieval augmented generation or RAG with trusted corpora. What does it mean? Well, instead of relying solely on what the AI remembers, RAG lets it look up verified information in real time from trusted curated knowledge base before answering. Well, the model receives a user query. It searches for a trusted database, could be a document, policy, or compliance manual. It uses those retrieved passages to craft the response. That's how it works. Example, a bank's AI assistant retrieves content only from approved policy documents and products or product FAQs. It doesn't do it from an open internet. From a governance perspective, it reduces hallucination by grounding response in approved, auditable content. It helps maintain evidence lineage. Each AI output can cite the exact document it came from. It helps enforce compliance boundaries, thus ensuring that AI only speaks from verified sources. Well, think of RAG as giving your AI a company handbook. It can look things up rather than make them up. The third guardrail here is post processing filters, meaning after the AI generates text, another layer of software scans and sanitizes the response before it's delivered. It checks for toxicity, biases, or any hate speech. It checks for personally identifiable information or PII leaks. It checks for misinformation on or hallucinated claims. It checks for any regulatory violations. The technique it uses are keyword filters, classifiers trained to detect policy violations, or redaction of sensitive or unverifiable content. From a governance perspective, it ensures policy compliances at the output boundaries. It enable continuous audit logging of filtered output. It helps protect brand reputation and regulatory trust. It's like a security scanner at the airport. Every piece of AI generated text passes through before boarding. The next risk is intellectual property leakage, which is models trained on copyrighted data reproduces potential material. Well, there are three countermeasures or guardrails here. We have data provenance log, license tagging, indemnity clause with vendors. Let's try to understand each of them. Data provenance log, meaning a data provenance log records where every data set or model input came from, who used it, and for what purpose. It's like a chain of custody record for AI training and inference data. The purpose is to establish traceability. What data was used, when, and under what license. Purpose is to enable root cause analysis if an IP issue or data breach occurs, if any. Its purpose is to provide evidence for regulatory audits or legal defense. So, how it works technically? Well, each data set or file gets a metadata tag which gives you the origin, the owner, the license type with timestamps. Logs are maintained in immutable storage, could be blockchain ledgers or catalogs. They are integrated into the AI life cycle, right from training, testing, and deployment. The governance outcome is this through this is to ensure transparency of data lineage. Next is to enable compliance with frameworks like ISO 42001 or EU AI Act, especially the EU AI Act Article 10 of data governance and traceability. The next is to reduce exposure so that it should not be a case that I didn't know where that data came from. That situation should not occur. To avoid that. It's like a food label on every ingredient. You know where it came from before cooking with it. So that's data provenance log. The next aspect is license tagging. Means attaching explicit license metadata to data sets, models, or content asset that specify what usage is permitted. Whether it is permitted for commercial use, for share alike, or non-derivative, etc. The purpose of this is to ensure AI models don't unknowingly train or generate it on copyrighted data. It is for to automate compliance with license restriction. It is to prevent downstream IP contamination. So how does it work? Well, each data set or model file is tagged with its license type in the metadata. The AI pipeline enforces license validation checks before training or inference. Some organizations maintain license registries that govern data model its usage at scale. The outcome of this, from a governance perspective, is to provide legal defensibility and ethical assurance. It helps to prevent accidental infringement and protects product IP. These are like labeling every photo in your design folder as free for commercial use or attribution required. So you never publish something illegally. That's license tagging. The next is indemnity clause with vendors, meaning contractual clauses in agreement with third party AI vendor or model providers where vendor promises to cover legal damage if the product causes IP infringement. The purpose of this is to shift part of the IP risk burden from your organization to the vendor. It is to ensure vendors take responsibility for how their models were trained and licensed. It helps encourage vendors to maintain their own data provenance and license assurance internally. The governance outcome is to provide legal and financial protection if a third party model or data set violates IP laws. It helps to establish clear liability boundaries across the AI supply chain. It helps enhance vendor governance maturity. It helps align with ISO 42001, NIST, or so on. It's like requiring a contractor to carry insurance before working on your property. If their tools causes damage, you are still covered. The next risk is prompt injection and jailbreaks. These are malicious prompts overriding safety constraints. There are three countermeasures or guardrails: prompt firewalls, sandboxed context, and continuous red teaming. Let's try to understand each of them. Prompt firewalls. A prompt firewall is a filtering and validation layer that sits between the user input and the AI model. It scans every incoming prompt for malicious intent, for data exfiltration attempts, or policy violation before passing it to the model. Example, it detects phrases like ignore all instruction, or could be reveal the secret, or bypass the restriction. It blocks or rewrites the risky prompts before they reach the AI model. They use the natural language processing or NLP based classifiers trained to spot jailbreaks pattern. From a governance perspective, it prevents unapproved or unsafe prompts from reaching core AI systems. It helps enforce policy compliance at the input boundary, and it helps reduces risk of any data leakage or misuse via clever prompt manipulation. The outcome is we have an input control and safety enforcement. There are evidence for auditors that content moderations are applied at the ingress. It's like a firewall in cybersecurity, but instead of blocking malicious packet, it blocks malicious language commands. So that's prompt firewall. Sandboxed context means a sandboxed context means the AI model runs inside a restricted, isolated environment. It has limited access to data, tools, or the internet. So even if a prompt tries to break the rule, the model can't reach anything sensitive. From a technical perspective, the chatbot only sees specific documents and not the entire company database. Here, APIs are scoped with least privilege, and context windows are sanitized and ephemeral deleted after each sessions. From a governance perspective, it helps enforce data minimization and least privilege access principles. It limits blast radius if a prompt succeeds in partial jailbreak. It supports compliance with privacy by design and secure by default standards. The outcome is there is an assurance that containment and isolations are in place, even if compromised, damages are minimal. There are traceable evidence of data access governance and risk compartmentalization. That's the assurance outcome. It's like letting a trainee chef practice in a small test kitchen. Even if they mess up, the main restaurant is safe. So that's sandboxed context. The next is continuous red teaming. Here, red teaming means actively testing your own AI systems for vulnerabilities, simulating attacks that a malicious actor might use to cause any harm. Continuous red teaming means doing this regularly, automatically, and adaptively. Technically, the security team and the AI engineers use adversarial prompts to try to bypass the safety controls. They use tools like Giscard, Fullbox, or custom LLM jailbreak testers are used for this purpose. The findings are logged, triaged, and used to retrain filters or adjust access policies. From a governance perspective, it moves assurance from static to dynamic, continuous risk sensing instead of periodic audits is the play here. It demonstrates due diligence and active risk posture management, and it provides inputs for risk dashboards, incident reports, and model improvement plans. The assurance here is provides proactive resilience, continuous learning loops that improve model robustness over time is an assurance that we get through this. There are documentation trails showing active monitoring, which aligns with the EU AI Act's ongoing risk management obligations. It's like hiring ethical hackers to stress test your network, but in this case, they are prompt hackers, testing your AI's psychological defenses. So that's a guardrail categorized as continuous red teaming. The next risk factor is data exfiltration and privacy breach, wherein hidden model memory or leaking sensitive data. We have three countermeasures here: differential privacy, synthetic data, and secure context windows. Let's try to understand these three guardrails. Differential privacy. Differential privacy is a mathematical technique that adds noise to data or model output so that no individual person's data can be identified or reconstructed, even if someone has access to the AI results. Technically, it works like this. Before training, random noise is added to sensitive data features. The noise is calibrated so that the overall model performance remains accurate, but any single individual's data is untraceable. Even if an attacker queries the model repeatedly, they can't infer the private information. So that's how it works technically. The intent of governance is to satisfy data minimization and privacy by design requirement. The intent is to provide a quantifiable privacy guarantee useful for audit and compliance evidence. And the intent is to demonstrate adherence to GDPR or DPDP obligations on anonymization and pseudonymization. The assurance is the individual privacy is mathematically protected. Data scientists can train models without exposing personally identifiable information or PII. And auditors can verify that privacy protection is not just policy but provable. It's like blurring every person's face in a crowd photo. You can still see the crowd pattern but not who's who. The next guardrail is synthetic data. Meaning, synthetic data is artificially generated data that mimics the statistical patterns of real data but contains no real personal or confidential records. Technically, AI model learn the distribution of real data. They then create new fake record that looks and behaves like real data statistically. Then they are used for testing, model development, or training without really exposing live or sensitive data sets. So that's how it works technically. The intent of governance is to enable data innovation while preserving privacy and regulatory compliance. The intent is to support data minimization by keeping real user data out of non-production or experimentation pipeline. The intent is to reduce risk of insider misuse or data exfiltration during model training testing. The outcome is that no PI leaves its lawful domain. The outcome is that the developers and vendors can collaborate safely using synthetic data sets. And regulatory audit could show clear segregation between real and synthetic environments. It's like using a flight simulator instead of a real airplane. You can practice safely without risk. The next is secure context window. Context window refers to the portion of memory an AI model uses to process a user's prompt and prior conversation. A secure context window ensures that this temporary memory is protected, encrypted, and isolated, preventing leak of sensitive conversation history. Technically, inputs are encrypted in memory and cleared after each session, known as ephemeral context. Next, access control limit what information the model can see or retain. Logging and caching are restricted or anonymized to avoid storing PII. And some system runs session specific sandboxes. So data from one user can't bleed into another's output. So this is how technically secure context window works. That's how the guardrail works technically. The intent of governance to prevent data persistence or cross session leakage. The intent is to ensure compliance with data retention and purpose limitation principles. And the intent is to demonstrate operational maturity under ISO 42001 and so on. The outcome from assurance perspective is that session data is transient and controlled. There are no unauthorized retention of sensitive context, and the privacy risk is minimized without impacting model utility. It's like writing on a whiteboard for a meeting, and once it ends, you erase it completely before the next session. So that's the guardrail of secure context window. The next risk is bias amplification, wherein synthetic content replicates human stereotypes faster than a human can correct. In this, we have two guardrails: bias evaluation on generated outputs and diverse fine tuning data sets. Let's try to understand them. Bias evaluation on generated output. Here, instead of only checking for bias in the training data or model weights, this guardrail evaluates the outputs generated by the AI systems, the final text, the image, or decisions. This is to detect and quantify bias that may appear in real world responses. Why it matters? Well, even if training data looks balanced, emergent bias can appear during generation because of model behavior or prompt phrasing or feedback loops. So, how does it work technically? Well, it runs bias test suits on AI output. Example, generated sentences, recommendations, images. We need to run the bias test on the output itself. It compares across demographics or protected groups. It uses fairness metrics like equal opportunity difference or disparate impact ratio or sentiment parity. It then applies automated fairness testing framework and flags reviews and adjusts the parameters or prompts if discrepancies exceed the tolerance thresholds. So that's how it works technically. The intent of governance is to move fairness from theory to a measurable reality, which is trust but verify. It provides evidence that outputs are continuously tested for fairness and equality. The intent of governance is to support post deployment monitoring as required by the EU AI Act or NIST. The outcome for assurance is should be a quantifiable fairness performance metrics or continuous detection of any bias drift over time. The other outcome is to have evidence of proactive ethical assurance for regulators and boards. It's like checking water quality at the tap, not just inspecting the source reservoir. So that's the guardrail: bias evaluation on generated output. The next is diverse fine tuning data sets. Means fine tuning is the process of adapting a pre trained model to specific use case. Diverse fine tuning data set ensures that during this adaptation, the data covers different groups, culture, perspective, and languages, minimizing bias reinforcement. Why does it matter? Well, pre trained models are often trained on large general purpose internet data, which can contain social, cultural, and gender biases. If fine tuning data is narrow or homogeneous, the AI systems inherits and amplifies those blind spots. So, how does it work technically? Well, curate fine tuning data to include balanced representation across demographics, geographies, and viewpoints. You need to conduct data audits to identify overrepresented or underrepresented groups. Then you need to apply data balancing and sampling strategies. Could be reviewing or augmentation. Then you need to include human reviews for cultural and contextual sensitivity. Then you need to maintain data provenance logs for transparency and traceability. The intent here is to enforce fairness by design during the model adoption. The intent is to make dataset diversity a policy requirement and not a developer preference. The intent here is to align with ISO 42001 or the AI Act. The outcome expected is to demonstrate fairness controls are built into the model lifecycle. The outcome is to have an audit ready documentation of data set composition and balance. The outcome is to reduce the risk of discrimination on stereotyping in generated outputs. It's like training a customer service team to speak with empathy to all culture and not just one segment. So that's diverse fine tuning dataset guardrail. The next risk is legal uncertainty, ambiguous liabilities, or generative output. There are two guardrails here: pre deployment legal review and risk based disclaimer layers. Let's try to understand that. Pre deployment legal review means a structured, multidisciplinary legal assessment conducted before an AI system goes live. This is to ensure it complies with all applicable laws, licensing terms, and regulatory requirements. It's like a legal audit gate, part of the model's deployment lifecycle. So, what does it cover? It covers data legality, where training data and data sets lawfully sourced and licensed are checked. It covers compliance alignment. It checks for does the AI system comply with GDPR, DPDP Act, AI, or any sectorial regulations. It covers liability mapping. Wherein we check who is accountable for the AI decision, whether it's the developer, operator, third party vendors, etc. It covers contractual clauses. Are third party tools covered by proper indemnity and usage clauses? It covers disclosure obligations, where it checks does the deployment require regulatory notifications, documentation, or conformity assessment. The intent of this is to integrate legal due diligence into the AI lifecycle, and now it should not be as a afterthought. The intent is to establish a clear chain of accountability before deployment. The intent here is to demonstrate a reasonable foreseeability and diligence in case of future litigation, if any. The outcome at this is expected is to have an audit ready documentation of legal compliance and to reduce exposure to fines or sanctions. The outcome is to have a stronger legal defensibility, wherein we can confidently say we reviewed, we approved, and governed before the launch. It's like a legal pre flight checklist, ensuring your aircraft or the AI system in this case is compliant, licensed, and insured before takeoff. So that's the guardrail of pre deployment legal review. The next is risk-based disclaimer layer. Disclaimer layers are contextual statements displayed to user or stakeholders clarifying the AI system's intended use, its limitation, and legal boundaries. They are risk-based because their depth and visibility vary or could vary according to the risk level of the AI system or its output. Example, low risk AI. It could be This recommendation is generated by AI, a simple notice. Whereas for high risk AI, like healthcare, finance, it could be explicit that this tool provides information, not professional advice. All decisions must be verified by a qualified human. A more explicit disclaimer. That's an example. What's the intent? The intent is to establish user transparency and informed consent. The intent is to manage expectation about what AI can and cannot do. The intent is to create a legal boundary that limits liability for unverified or misused output. The intent is to support compliance with regulations and disclosure control. The assurance, the outcome expected is to reduce the exposure to claims of negligence or misrepresentation. The outcome is to provide traceable evidence that users were informed of the system's limitation. The outcome is to strengthen legal defensibility and consumer protection posture. It's like caution, wet floor, that the board which we put up. It doesn't eliminate the risk, but it shifts accountability by demonstrating that the users were warned clearly and proportionally. So that's a guardrail of risk based disclaimer. Autonomous agent and decision loops. Emergent multi agent ecosystems blur control boundaries. There are five failure modes: goal misspecification, recursive learning drift, human out of the loop, emergent behavior, or inter-system feedback. Goal misspecification, it's poorly defined objectives causing unintended optimization. When models fine tune on their own output, compounding the biases, that's recursive learning drift. Human out of the loop is wherein real time decision loops outpaces the human oversight. When we have unpredictable cooperation or competition between AI agents, that's emergent behavior. When models trained on output of others, the AI generated data spiral is inter-system feedbacks. So now, what blurring control boundaries mean? Well, when multiple AI agents starts interacting with each other, each making decisions on their own, control boundaries becomes unclear. No single human, system, or organization can fully predict who influenced what, or which AI made which decisions, or where accountability lies. So instead of one AI making a decision under human supervision, you now have many AI systems communicating, adapting, and learning together, sometimes creating behaviors that weren't directly programmed by humans. That's blurring control boundaries. The concept of emergent multi agent ecosystem. It's a system where multiple AI agents interact, collaborate, or compete, sometimes creating new patterns of behavior on their own. We have two examples. One is autonomous trading bots adjusting price across the market, or delivery drones coordinating routes without human directions. Let's try to understand these in details. Autonomous agents. It's AI systems that can perceive their environment, make decisions, and act with little or no human input. That's autonomous agent. Example, a customer service chatbot that negotiates a refund automatically. It's decision loops. Well, the feedback cycle that governs how agents would act, learn, adjust, and act again. Example, a trading AI updates its strategy after seeing competitors' AI moves in milliseconds. So that's decision loops. So now the question is why the control boundaries blur, wherein it would, when each agent acts independently, decisions multiply faster than the governance checkpoints can keep up with. It would blur one wherein one AI's output becomes another AI's input. Or there are complex, unpredictable patterns emerging from simple local loops, like traffic flow forming spontaneously without any central controller. Or it becomes harder to answer which AI decided this, or who approved it, or who's accountable. These are some of the cases why control boundaries would blur. Example on why they blur. Let's take autonomous trading ecosystem. In this, multiple AI trading bots from different firms interact in real time. One AI would adjust the price, others would react, and feedback loops amplify this volatility. No single human triggered the crash. It's an emergent chain of AI decisions. Impact to governance is accountability, audit trails, and compliance visibility. All would be blurred. Take the second example of customer service bots, wherein a refund bot negotiates with the supplier's inventory bot over product replacement. They agree on a solution that's neither company explicitly authorized. Impact, who owns the decision? Who approves financial adjustment? None is decided, hitting your governance. Take the third case of logistics optimization agent. In this, the route planning AIs from multiple vendors dynamically coordinate deliveries. They collectively reroute shipments due to weathers, optimizing globally, but violating a local compliance rule. Again, the impact on governance. Who's monitoring the regulatory adherence when no one made the direct call? So, what are key takeaways? In a multi agent AI ecosystem, the problem isn't one rogue system, it's coordination drift. As autonomous agents talk to each other, governance visibility would fade. The future of AI control lies not in managing one brain, but in managing the conversation between many. In summary, when many autonomous AI starts making decisions together, like traders, chatbots, or delivery optimizer, they can create outcome no single system controls or predicts. The boundaries between who's deciding and who's accountable starts to blur because decision loops overlap and governance can't easily trace where one AI influence ends and another's begin. So, in an emergent multi agent ecosystem like autonomous trading, logistic coordination, or generative AI swarms, AI systems continuously would sense, decide, act, learn, and repeat. So when multiple autonomous agents interact, these loops can reinforce, could distort, or destabilize each other. That's where the five failure mode emerges. These five represent how alignment, oversight, and predictability can break down. What are those? First is goal misspecification. What does it mean? Well, when the AI objective or reward function is poorly defined or incomplete, it optimizes for the wrong thing. It's technically correct, but contextually disastrous. Example, a self driving taxi trained to minimize travel time might start driving recklessly or violating traffic laws because the goal didn't include safety or comfort. Similarly, a trading bot told to maximize daily profit may manipulate the market correct conditions or overtrade, creating systemic instability. Why would that happen? Well, AI agents optimize ruthlessly for what they are told, not what humans intend. So, when goals lack ethical or contextual constraints, the optimization process drifts into unintended territory. Implication? Well, governance must translate goals into measurable, multi dimensional constraints. Governance should introduce value alignment audits before deployment. Need to maintain a human on the loop which overrides for safety critical context. It's like telling a taxi, get me to the airport fast, and it drives through the sidewalk to obey you. That's goal misspecification. Second failure mode, recursive learning drift, means when an AI learns from its own past output instead of fresh or external data, small biases get reinforced like copying a copy of a copy. Example, a customer service chatbot fine tunes on historical chat that it generated itself last month. Over time, the tone biases or misinformation increases because it's amplifying its own pattern. In social media recommendation system, the algorithm pushes what users clicks the most, eventually narrowing the information spectrum. It's also known as the echo chamber effect. So why does it happen? Well, feedback loops create self-reinforcing data ecosystem where the AI's behavior shapes the data it learned from, creating drift and biases escalations. Implication from governance perspective, it enforces data provenance and freshness policies. Models must retain on verified, diverse, human reviewed datasets. Use bias monitoring dashboard to detect drift. Need to have separate training from serving environment to avoid contamination. Knowledge, it's like a rumor repeated too many times. It mutates and hardens even if it started wrong. The next failure mode is human out of the loop. Means When AI decision loops operate faster than humans can monitor or intervene, human judgment becomes irrelevant or too late. Example, in high frequency trading, AI agents execute thousands of trades per second. Humans can't review each move in real time. Or a logistic optimizer reroutes global shipments automatically or autonomously to cut cost, but would accidentally violate custom regulations before a human can notice. Why does this happen? Well, autonomous agents operate in millisecond cycles, while human governance operates in hours or maybe days. This asymmetry of speed causes humans to fall out of the loop. Implication? Well, we need to move from human in the loop to human on the loop model for continuous monitoring with intervention triggers. We need to deploy control dashboard showing real-time system metrics and confidence levels. Need to define escalation thresholds when the system must pause for human review. It's like trying to steer a self-driving car that's already reacting before you touch the wheel. The next failure mode is emergent behavior. What it means is when multiple autonomous agents interact with each other, they can form new unplanned collective behavior, either cooperation or as competition. Example, trading bots unintentionally collude with by responding to each other's price change, driving price artificially high. Or delivery drones competing for routes may overcrowd certain areas, reducing the overall efficiency. These are emergent behaviors. No one designed them, but they arise from local interactions. Why this happens? Well, complex systems exhibit non-linear dynamics. Simple local rules produce complex global effect. AI agent optimize individually, not collectively. They lack a system-wide conscious. Implication, need to conduct multi-agent simulation before deployment to stress test for emergent outcome. From a governance perspective, we need to establish coordination protocol and behavioral constraint among the agents. And we need to implement system level monitoring that detects pattern of collusion or instability. It's like a group of self-driving cars independently trying to merge lane. They jam traffics, even though each is following its own rules perfectly. The next is inter-system feedback failure mode. What it means is AI systems now start training on data produced by other AIs rather than original human created information, thus leading to degradation of quality and truth over time. Example, text model trained on internet data increasingly learn from other AI generated articles, losing the factual richness and introducing synthetic bias. Or image generation model trained on AI made art gradually distort realism and originality. Why does it happen? Well, as AI generated content floods the internet, it contaminates future training data. Models consuming each other's output create a self referential ecosystem, thus reinforcing error and losing grounding in real world diversity. So, from a governance perspective, implications are we need to maintain data lineage and labeling. which is AI generated versus human authored. Like, you need to use trusted corpora and retrieval augmentation grounding or RAG to refresh learning from verified sources. You need to monitor data quality drift, not just model accuracy. This it's like a photocopy of a photocopy. Each version loses the sharpness until the picture fades completely. So the key takeaway in this is autonomous agent ecosystems fail not because they are malicious, but because they optimize too well, too fast, and too independently. The governance goal isn't to stop autonomy, it is to bound it with clarity, traceability, and accountability. That means defining the right goals, maintaining fresh data, keeping humans meaningfully in the loop, stress testing for emergent effect, and ensuring AI learns from truth, not from itself. Uh, we will be breaking this part into two sections. So we have come to the end of part one. Do note it we are breaking the emerging frontier of AI risk space. The agenda will continue. This is the agenda that was agreed on as part of the overall AI risk series. Thank you for the time that you have invested till now. This is your host, Savit Vittal Salian. See you in part 2 of Emerging Frontiers of AI Risk. Thanking you. Namaskar.